Bismillah Rahman Rahim. In the last lesson, we learned about the weak and strong acids and couple of reactions. Today, we're going to move forward from them. So here we're going to discuss about the neutralization reaction. A brief intro I already gave you about this reaction. What happened now? It's okay. Let now start is okay.
Yes.
Okay. Here simply we just going to discuss about the equation, and inshallah you will get the whole idea through this equation, and the definition of the neutralization reaction is also written here. So what's going on in this reaction? You can see that this a simple acid, okay, hydrochloric acid HCl. Here you have a base, that is NaOH. They react together, and what they form, sodium chloride. Actually, that is a salt and a water molecule you get here. So the simplest definition that's also mentioned here, a neutralization reaction occurs when an acid and a base to produce water, H positive plus OH in this way. So here, like this, from acid, H positive hydrogen ions comes, and from this base, OH negative ions comes, and they join together and they form a water molecule. Now the remaining part of the reactants, mean to say from acid like Cl, chloride ion, and from here sodium ions, they combine together and they form a salt. This is called neutralization reaction. Any question about this reaction? You can raise your hand or you can ask, even in the text. Easy. Simplest reaction. Yeah.
Can you?
Yes, please. Okay, no problem. Okay, no problem. Listen, what happened? Neutralization. Here you have something is acidic in nature, like HCl, and the second thing is basic in nature, like sodium hydroxide, NaOH. This base and this acid, when they react together, they're going to neutralize each other, or you can say that cancel each other. So when they cancel each other, you get a salt and a water in the product. So they're gonna cancel each other and they neutralize. After checking the pH of this reaction mixture, where you get the solution of these two products, its pH will be 7. Why? Because this solution neither acidic nor basic or alkaline in nature. So this is called neutralization, like the neutral gear in your car, where car is not move forward or backward. In the same way, according to pH scale, this product become neutral. Hope you understand. As we have shown, when both hydrochloric acid and sodium hydroxide dissolve in water, the ions separate completely. We may therefore write like this. These are the ions from HCl, H positive, and Cl, chloride negative ions. From this sodium hydroxide, you can see that Na positive and OH negative. So what happened? This H positive and OH negative combine together and they form a water molecule. And here chloride negative and sodium positive, they combine together and they form NaCl salt. Easy. Same thing that I explained here, you're gonna write in the equation form and explain you again. Now, you will notice that certain ions are unchanged on either sides of the equation. They are called spectator ions and are usually taken but out of equation. The equation now becomes, even here they are there is no change occurs in these two ions, mean to say chloride and sodium, they're in the same form, but here the change occurs. How? You can say that H positive and OH negative, they form water. This type of equation is known as ionic equation. Why? Because there are ions like H positive, and OH negative, hydroxide negative ion. The reaction between an acid and any alkali in aqueous solution produce water and can be summarized by the ionic equation. So this the simplest formation of water from acid and base, and this is called an ionic equation. If somebody asks you, especially in the quiz or in the exam, what is an ionic equation? You can easily define the definition. In aqueous solution produce water and can be summarized by this as an ionic equation. It shows the ions which cause acidity, very well, H positive ion or proton donor reacting with the ions which causes alkalinity, OH negative ions to produce neutral water molecule. As I explained you here above, in this equation, all the ions from acid or base, they combine, or you can say that they cancel each other's effect and they form a neutral solution. Here, it's cause the acidity, very well, is due to H positive ion, and the alkalinity is the presence of OH ions. Now, in the end, after the completion of this reaction, during neutralization reaction, you get water. So the water pH 7. It's not towards the base or not towards the acid. So till here, any question, please? Yes. Okay. Aqueous solution of acid contain H positive ion and the aqueous solution of alkali contain OH negative ion. We know very well, and we already done this thing. Now, about the formation of salt, we come towards here. So this in the equation that we just summarized and discussed in detail. Here it's going to tell you about the formation of salt, how a salt is formed. In the example on the page, sodium chloride was produced as a part of the neutralization reaction. Compound formed in this way are known as salts. This one, NaCl. This is called your salt. A salt is compound that has been formed when all the hydrogen ions of the acid have been replaced by metal ion or by the ammonium ion. What is metal ion? You know that here, this sodium that as a metal atom, Na, it's replaced is all OH ions with Cl. Okay. So what is going to tell you? Listen again. Metal ions or by the ammonium ion, NH positive 4. Salt can be classified as those which are soluble in water or those which are insoluble of water. Now here it's going to tell you the types of salts. The one you can easily soluble like sodium chloride, NaCl, when you dissolve in water, it is simply dissociate. You didn't find where the sodium and chloride ions goes. But another type of salts which are insoluble in water. The general solubility rules of the salts are, there are a couple of rules. Let's to see them. What are the rules of the solubility of ions? All sodium, potassium, and ammonium salts are soluble. This is the first thing that you need to remember. All nitrates are soluble. All chlorides are soluble except lead and silver. It means if the chloride mix with lead and silver, they will not going to soluble. All sulfates are soluble except barium and calcium. And again, the third one is here, lead, Pb. Okay. All carbonates and hydroxides are insoluble. What it means? They are not disperse or dissociate in water except sodium, potassium, and ammonia. you can say that a couple of rules that you need to remember in the same way. Okay. Now, the next part here, if the acid here, it's going to show you being neutralized in hydrochloric acid, salt called chloride and formed. What it's mean? The acid you choose here, you know that is HCl. Understand? The above equation, here you can see that this is the acid that you choose. Being neutralized is hydrochloric acid, salt called chloride. Other types of salts can be formed with other acids. As summary of the different types of the salts along with their acid they are formed is shown in table 8.2. Let's go towards this one and see the types of other acids that are we formed here. So you can see here carbonic acid mean to say carbonates, ethanoic acid, ethanoates, hydrochloric acid, just we done, chlorides, nitric acid, nitrates, sulfuric acid, sulfate. So this is the simple example and the name, and after that, what type of salt you obtain during this reaction, you can see here. Now, the other part of the lesson in which we're going to discuss about the oxides and its
Yeah.
type. Yes, please.
And the acid and type of salt.
Yes.
Acid, it make the reaction with what? So it can make the type of salt.
Yes, like the same way, because they're gonna choose this. It's depend upon the part that is attached to the proton, mean to say hydrogen. Here, for example, in this case, as we learned before, if you remember, just a minute, this one here, like hydrochloric acid, HCl, so chlorides. In sulfuric acid, you have H2SO4. This SO4 is actually the sulfate. Okay, so this the part that is attached to H. Same like here nitric acid, HNO3. So these are the nitrates and here H is attached with this one. Okay.
Yes, but you said the acid it will make a reaction with what? So it can make the type of salt
No, this
like
depend
carbonate.
upon, yeah, this depend upon the part that is attached to this one. Okay, inshallah, in the next, you can say that the phase we're going to discuss this thing again in detail. But here it's going to tell you about the naming only, how you give the name to their salts. Types of oxides. There are three types of oxides: non-metal, such as sulfur dioxide and carbon dioxide, are acidic. You need to know, that is very important part, if these are the non-metal oxides like sulfur dioxide and carbon dioxide, they are acidic in nature. Their pH shows towards 1 or less than 7. In aqueous solution, they produce aqueous hydrogen ions or H positive ions. Or you can say that proton donor. Metal oxides, however, are basic oxides because their pH goes more than 7. If these oxides are soluble, they will dissolve in water to produce aqueous hydroxides, OH negative ions. Same like we learned about acid and base. Now, the third type, for example, copper, Cu, and calcium oxide, these are the examples of basic oxides. Okay. Now, the third type, if you remember that,
Here what is
which one?
OH negative?
OH negative. This is hydroxide, OH negative. If you remember that in alkali, we'll learn about this NaOH, sodium hydroxide. This OH actually that indicates the basic character, or you can say that alkalinity in the solution. Okay, so you can say that if OH group is attached, it's going to tell you that is a base. Okay, and if H positive is present and gives in the aqueous solution that represent the basic character. And if OH negative comes from anywhere, that's going to show you about the basic character. Now, Ahmad, easy?
Yes.
Okay. Now the third type of the oxides, this is in between both of them. Why I say that the in between type? Because we name them as amphoteric. If you remember that, we know about the hybrid cars. Yeah, some cars you can drive, or they are working on fuel like benzene, petrol, or gases, but the some cars at the same time working on the electricity. So we can say that, like the Tesla, they only work on electricity on batteries. So here couple of, you can say that the oxides, they work on, or they show both characteristics, so we give them a special name as amphoteric. What we call them? Amphoteric oxides. The third type of oxides and the rarest are those described as amphoteric. These oxides react with both acids and alkalis to produce salts. Definition is okay? Example of amphoteric oxides are zinc oxide, ZnO, aluminium oxide. So these are the types of three oxides in which you learned about. First one is your acidic oxide, second is basic oxides, and third, they show both characteristics. We name them amphoteric oxides. Till any question here? Okay. Now methods of preparing double salts. That is maybe a new concept for you. So please focus and try to understand this thing. What is the meaning of double? Double, it's very easy when we come there, but here it's going to tell you the first thing here, preparing soluble salts, which you can easily prepare, and that is soluble. Okay, so let's see this one. Here, the methods, there are 4 general methods of preparing soluble salts. These involve the reaction of an acid. Like excess metal, you know very well, metals are sodium, potassium, these are the metals. Excess insoluble carbonates, mean to say CO3, like this. Excess insoluble base, OH, okay? And alkali by titration. The titration actually, my dear, is the process. If you remember that, I explained you the titration is against acid and base, and you're going to find out their endpoint. In lab, you will do this practical, especially to find out the endpoint of the reaction by this method. Okay, so let's see about the first one here, the acid plus metals.
Yeah.
When, yes,
What is excess metal? What is
excess,
excess in?
yeah, excess mean more. For example, you need something, it's more than its capacity. Okay,
Okay.
now the first here, it's going to tell you about when you're going to react any acid with metal. Okay, so what happened? This method can only be used with the less reactive metals, such as aluminium. If the metal is less reactive, then you use this type of method. It would be very dangerous to use a reactive metal. Why? To use this method to reactive metals, maybe there will be explosion, and the reaction is very fast, so quick, so you can't do this reaction with reactive metals, only the less reactive metals. Hope you understand the term less reactive. You understand, or you want to I explain this thing?
Again,
Sorry?
we didn't understand.
Okay,
Teacher,
yes, my dear.
less reactive means like it doesn't react
Yes,
sometimes, or
yes,
it doesn't have
very.
much electrons.
Very well done, very nice. Sometimes the less reactive actually a term is used, the reaction is not going on easily. Maybe it need some, you can say that catalyst, some conditions, high temperature like this, or even the reaction go through, it will not give you a lot of product. There may be lot of side chain or byproducts, whatever the products you want, it's not going to give you. And you can say here the more reactive, it's maybe quickly within seconds. Okay, so like furious reaction is going on. Well done, very nice. Okay, the metals usually used in this method of salt preparation are the metal metals, that is magnesium, aluminium, zinc, iron, and tin. This all the metals, their first letter is they taken and then they give the name. Understand? A typical experimental method is given below. So from acid, you know that what will come. Maybe anything, like you can take an acid like HCl. Again, we will take here. That is an acid. And from here, any metal you can choose. Like I'm gonna take here a metal like iron, Fe. Okay. Now after that, what happened? A salt is formed. How? This FeCl, that is a salt, and here this hydrogen goes there, plus H positive. So that you get here. Understand? It is simply,
So this is how I can add the acid and metals.
yeah, very easy. You can take the acid and you can pour the metals in the acid, and then you can find your product. Inshallah, it will come in the next phase. We will going to see there the
Yeah, you
equation.
take only Cl from
So
the HCl, you take Cl and Fe only.
any, no, why Fe? Look here, how many these are
No,
metals?
no, the Cl,
Yeah, see, here
not the Cl.
even you can choose here H2SO4. You can use this
Yes,
acid. You can use any acid. Okay. So here you need
yes,
excess
but
metal. Yeah.
you take only Cl from HCl.
Yes. Every time this part will come in. Look how actually first thing you need to know how an acid dissociate. How? Okay, look this one. For example, here HCl. So these are the two parts. This is H positive and Cl negative. It dissociate in the solution like this. H positive plus Cl negative. So this Cl is go towards a metal. Okay. And this H positive go next way in the form of hydrogen. Understand?
Yes.
Okay.
Wait, can you?
Sorry.
Okay, no.
Look here. It's going to tell you here in the equation form. So excess magnesium ribbons is added just as a metal you add to the dilute hydrochloric acid. By using an excess magnesium ribbons, we are making sure that all the acids has reacted and some magnesium is left at the end of the reaction. During this addition of the effervescence of observed due to the production of hydrogen gas. So the smog or the effervescence is coming, that's mean these are the hydrogen gas that is going on from this reaction. Okay, so it's going to show you here like this. H positive, it take electron from the metal and then you get hydrogen gas, and the magnesium like here and the chlorine from HCl, these two combine together and you get here a salt MgCl2. And what you get here, that is your hydrogen gas that is coming out, like the same that you get here. So it's going to show you this reaction down, like here, as I explained you, how they react with each other. Look, you are pouring acid here in the china dish or in the petri dish, and the ribbons are here. So when you pour acid in them, the metal is going to react with this and then the product is formed. So the excess magnesium is removed by filtration. You know very well what is the filtration process. Yes. What is filtration?
Filtration.
Yeah.
Filtration.
Yes. Okay, no problem. Just a minute. I will tell you.
You can filtrate with the chloride.
From look, this is a paper, okay, filter paper. You pour the mixture, for example, sand and water, and you want to get water out. So this in the conical flask, it will become like this, and the liquid will coming down, and all the sand particles are stay in the filter paper. Only the liquid is coming out. Okay, this is a simple filtration. Whatever the solution you get here, you just pour this in this filter paper, and solution of the salt is coming down like magnesium chloride, okay, and the excess magnesium, that is, you can say that in solid form, will not going down. The magnesium chloride solution is evaporated slowly to form saturated solution of the salt. The hot concentrated magnesium chloride solution produced in is tested by dipping a color glass rod into it. If salt crystals form at the end of the rod, the solution is ready to crystalline, and it is left here to cool. So if you will touch, you know that how either the solution is concentrated or not. You going to check out with the rod, to dip and take the rod out. If the crystals are formed, then you evaporate the excess from it. Any crystals produced on cooling are filtrated and dried between clean tissues. So the process here, it's another way in which you're going to dry it and remove the excess, you can say that the moisture from them, and you get your pure crystals. Now the second way in which you're going to react acid with carbonates. Let's start this one. Ready?
Yes.
Okay. So here again we have a salt, sorry, acid, because we're going to react acid with carbonate. So what you get here, almost here in your reaction, you're gonna get almost three products. One is your salt, that is understood. Second is water, and the third one is your carbon dioxide. So how the reaction is going on? Let's see. This method can be used with any metal carbonate and any acid, providing the salt produced in soluble. The typical experiment in similar to that carried out of an acid and a metal. For example, copper 2 carbonate. This the example here. CuCO3. That is the formula of this carbonate, would be added in the excess of dilute nitric acid. Now here we use HNO3, that is the chemical formula of nitric acid. Effervescence will be observed, mean to say the fumes that going out due to the production of carbon dioxide gas. In the last method, we also get effervescence, but these effervescence due to H2, hydrogen gas. Okay, my dear, don't forget. But here in this reaction, we get these effervescence due to carbon dioxide gas. Now let's see the reaction here, how the products are formed and what will be the procedure of this one. Look, here you have copper carbonate. It means this bond is broken down from here, and this is going to break from here. So in this way, copper and nitrate combine together, Cu plus NO3. They combine together and they form a salt. Very easy to know that. This thing, the salt, is clear in your mind. Now, the second part, this carbonate, CO3. What going on here? This CO3 is break down into CO2, carbon dioxide, and one oxygen atom, or you can say that the molecule. Okay, so this carbon dioxide move here in the same form and to get here carbon dioxide, and this oxygen is combined with this hydrogen, and both of them what they form? Water molecule. Understand? Yes, please.
Yes, sir.
You understand this equation?
Can you but explain the last part?
Okay, no
Last
problem.
part.
The last part is written here again. Look, the first about the salt formation is very easy. Metal carbonate contain carbonate ion CO3. In this reaction, the carbonate ion react with the hydrogen ion in the acid. Look, this H that comes from the acid. Look this. Okay. And these carbonates ions come from carbonate and they react together. From here, CO3, what it means? CO3, it breaks down into CO2, carbon dioxide, and oxygen. So this carbon dioxide comes in the same form, and this oxygen atoms move with the hydrogen atom, and then they make water molecule. When excess carbonate has been added, you will see it collects at the bottom of the beaker, and the effervescence will stop. Easy, my dear?
Sir, what is effervescence?
You can say that these are just like a fumes, smoke, what you say, bahur, this coming out from the reaction. Okay. Okay.
Okay.
Okay. Now, it's written about the titration, and the last part of this one, we will going to see the excess. I think it's okay. You can read it out. No problem here. Let's go towards acid plus alkali. Soluble base. Here we're going to see this one. So before to go next part, I think there is only almost 3 minutes are remaining. So it's better I will send you the new link because then we will complete the whole topic. Okay. So I'm going to send you the new link.
Okay.